All right. So good morning. Good morning to you. And as I said yesterday, we will return to finish off this lesson of introduction to CAN bus. I just want to finish it off. And so as you see, I have the graph up. We will discuss the graph a little bit, and we'll go into depth. We'll go in depth with this topic today, and try to finish the portion that I left off from yesterday. So if you see, I'm showing the graph on the screen, and this is a CAN uh, data link pulse, right? That is it's being produced by the transceiver, right? The transceiver is sending this information or this pulse onto your system. Okay. um Let me go back, right? So the transceiver the transceiver in the ECM is sending out this pulse, this information pulse, right? This pulse, which is a information that is either going to a monitor or is going to a next ECM, sending information to a next ECM, sending information to your monitor, and so that your operator or whoever is looking at your HMI, you can have information from your ECM, and it will tell you what is happening on the engine itself. For example, oil pressure, oil temperature, right? The coolant temperature. All of that is coming off from your ECM, is sending information on this pulse. Okay, so on this pulse here, there's information, and remember that this pulse is riding above the zero line. Your zero line is below, so there is no negative on this pulse here. Okay, and remember, this pulse again, I must stress, I must emphasize that this pulse is coming from your transceiver. This is the output of the transceiver from the ECM, right? It's sending this output, and this pulse here, right, it's in a binary format, in a binary language, right? It's in bits, right? So what the transceiver is sending out, right? Zero and ones, zero and ones, they're in bits. And remember that the pulse, the top part of the pulse, if you can see, very it's a mirror of the top and the bottom, the mirror of the top and the bottom. But you remember that when this the can high is upwards, and so we can say today that the can the can voltage, because in the electrical signal now, the can high voltage is 3.75, right? It's going upwards. Remember, your maximum voltage on this graph is 5. So above, you will see you have that maximum 5 volts, and you have a binary, right, on the top, right? If you can see that, okay. If you can see that, you can let me know, right? Because your dominant voltage is just on that, what is tapering off to the top of your pulse. It's tapering off on the top of the pulse. Let me go down a little bit more. So it's tapering off at the top. This is your dominant there. Your dominant is on this thing. This is your dominant voltage. Your dominant voltage, right? On a digital language, would be zero, right? Zero bit, right? So you have 0 bits on. We can call your dominant voltage 0 bits, right? Now your recessive, your recessive, right? Your recessive. we're gonna discuss your recessive, which is at 2.5 volts, right? We're gonna discuss that. And on this line here, you call is the recessive bit. So you have dominant bits, right? And you have recessive bits. And on the recessive bits would be what? One, right? So dominant, we will call it 0 bits. Recessive bits, we will call it one bit. I do hope you get that. All right. I do hope you get that, right? Because your dominant, your dominant, right, voltage, we will call that uh your 0 bits. Okay. And your recessive voltage, we will call that, right, 1 bit. So we are looking at this thing here, and the information as or on the, or your carrier that is going, that is sending in information, right? This is your CAN data link, right? So your CAN data link, and I must mention that uh your dominant is 0 bits. We can call that and known as your dominant bits, right? So 0 bits are also known as dominant bits, right? 0 bits are dominant over 1 bit, right? It's dominant over 1 bit, and 0 bits are represented by a differential voltage such as 2.5, right? So it has a differential voltage of 2.5. Why you have a differential voltage of 2.5? Because between here and there, right, the differential is between this. You have a line uh, here. That is your differential. Between here and here would be your differential, right? And so therefore your differential would be what? 2.5 volts. So if your recessive voltage is 2.5, right, on your recessive, on this line that we're calling the recessive voltage, right, we call in here, this is the recessive voltage, because remember this pulse is riding above 0 line. Okay, I want you to have that in mind. It's riding above 0 line. It's not zero. It's in the positive quadrant. All right, so it's on the graph. It's in the positive side. It's not on the negative side. It's on the positive side. If you see below this zero, we have a driver logics. Okay, but above, right, that is where your CAN bus is being is above the 0 line. So I must mention here that CAN follows a convention in electronic, right, signal called a non-return to zero, right, inverted. Non-return to zero inverted is this here, inverted on the CAN low. Non-return, it didn't go back, right? It did not it did not return to zero here, right? If you look at it carefully here, this would be 1.25. Your differential, right? Your differential, I can determine, because if my recessive is 2.5 volts and my CAN high is 3.75, right? I already know what is my CAN low. My CAN low is the subtraction of the 3.75 and the 2.5, right? And that will give me the 1.25 at the bottom here. So when I'm taking my multimeter and I'm testing the two wires on the CAN data link, you have a CAN high and you have a CAN low. But my multimeter is going, the multimeter, my negative lead is going on the ground or the chassis of the equipment, right? You find a ground on the machine, right? You know the ground, right, on the chassis of the equipment, and the positive part of it would you now would take that the positive lead, and you test your can high, and you see you getting 3.75. You go to your can low, you should get 1.25, and your can low will always be lower than your can high. So if you getting a high voltage, a higher voltage on your a higher voltage than than on than on your can high, then you have a problem with the can data link, right? Because you're not supposed to get the voltage is not supposed to be higher higher on the can low line than the than the uh than the than the can high. So the can high always higher than the can low. So it cannot be opposite. Because look, we're looking at a graph, right? It would never be higher. Can low will never be higher than can high. And so that is what we're expressing here today, right? When you're measuring on you want to measure, right, the voltage, the electrical signal voltage that is coming out, right? And remember that the transceiver is dealing in a series, is sending out a series of bits. Look at what the transceiver is sending out, right? Right? It's talking in language 0 1 0 1 1 0 0 0 1 1 0 0 that is what the language, the binary language, the transceiver is talking, right? So there's the binary system that is happening here in your CAN bus that is sending information, right, onto onto your electronic monitors, and they were getting information from the ECM, and also your other ECMs in the circuit. You might have several ECMs in the circuit. I'm getting a message. I'm looking at it, and so uh, you're getting information that is traveling. And remember that this pulse here that is going, it is going in terms of time. So you have changes taking place on this pulse, right? When you use your meter, you will see the changes. All right, you will see the changes in time. And if you look at this pulse, you see that it's not always up, but the minimum is 2.5, and your maximum here is 3.75. And so my differential, right? My differential, I will have a differential between between my dominant voltage, the inverted part, and the 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 top part. So I have inverted, right? The inverted would be the bottom, right? That's why I'm saying that this system, it's a non-return to zero inverted. Non-return to zero inverted, NRZ. Okay? I want you to pick that up very clearly today. And because we're closing off this topic today. We're closing off this topic today, right? I want you to pick it up. All right. So when let us look at it, right? The signal on the two CAN lines express the same sequence of data, but their amplitudes are in the opposite. So the amplitude is in the opposite, right? They're expressing the same data, right? But the amplitude is in the opposite, right? So if a pulse on the CAN high lines the CAN high lines goes from 2.5 to 3.75, then the corresponding pulse on the can lower lines goes from 2.5 to 1.25. We know that. We know that. We know that. We are expressing that. We are expressing that. We know that. We know what we're looking for. Because if I go to can high with my from ground to can high and I get in 3.75, if I'm getting 4.4 point, let me say 4.5, right? If I'm getting 4.5 up here, right? What I supposed to get down on the other side? Can somebody send that to me? Because if I'm getting 4.5 on my can high, when I measure can low, what is the expected value of your voltage, right? What is the expected value of your voltage, right? Is anybody out there could tell me? Huh? So it's 4.5 at the top. I measure. So what I when I measure can low, what is it? It's supposed to be lower than 4.5. So what are gonna be? It's gonna be 2 volts. All right. So if my can high is 4.5, then and I know my recessive is 2.5. It's gonna be half of the 5 volts, right? It's gonna be half of the 5 volts. So I take my it's 4.5 minus 2.5, right? And I will get 2. So when I'm measuring can low, I'm looking for 2 volts. And this is 2 volts DC, not AC. So your meters on DC, please. Remember your meters on DC. We're measuring DC voltage here. Okay? All right. And so in the common voltages on this system, we use a very common voltage which is 2.5, and the differential produced by a 5-volt transceiver set up in our example. So we will use that. It is possible to use other voltages in the CAN bus network, right? Especially if you keep the differential voltage at 2.5, right? But you may need to make a custom adjustment to your equipment. All right. So let us look. This is already designed, and we know we're looking on the tool. If we're getting a CAN data link error, then we know our CAN data link or a data link is down. The monitor is not communicating with the ECM, and it's sending out, say here, it's an error. I'm not receiving anything from the ECM. All right. So therefore, you can put now your meter. You can check with your meter from ground to can low or can high, and you can see the voltage on the bus. What is the voltage on the bus? And remember, if you have several ECMs on that bus, then you need to remove, you only need to have one ECM at a time. You troubleshooting, right, on a CAN data link. And let us say you have 4 ECMs on your bus, right? The 4 ECM, then therefore you need to remove 3 of the ECM. You need to test one ECM at a time. What is the voltage that ECM is sending out from the transceiver, right? What is the voltage, right? And then you disconnect that one. If that is okay, you go to the next one, and you check voltage. You disconnect that one, you go to the third one, you check voltage. You disconnect that one, you go to the fourth one, and if you get in terms of different voltage, or there is no voltage, right, on the fourth one, or whatever, all of those that you check, and you know you're having a problem somewhere, right? That one of the ECMs are not working, right? And it's given a candidate link error, then therefore you can pick it up. But you cannot test the candidate link, right, with all the ECMs connected. You need to test them individually so that you will know what voltage each ECM, or and we call it TAN nodes, are sending out into the system. All right. So we need to do that individually. We cannot test all the ECMs because all the ECMs they are sending out voltages, right, on this data link or on the CAN bus, right? So on the CAN bus, right, there's information going back and forth, but we can only check that one at a time. All right, we can only check that one at a time. So let's move on because we have to finish this topic today, and we already 21 minutes in. And so a while we remember we were talking about voltages, right? Let's take a minute and look at what is happening. We been depicting signal throughout this lesson as a pulse. We spoke about this thing as pulses on a graph. The pulses on a graph, right? Like the image shown here, right? Uh, this is a pretty standard way of representing a signal. So this is pretty standard way in representing the signal. But it's really important, right, to remember that graphs like that, like this, what is being shown, how the bus voltage changes over time. So the bus voltage is changing over time. So in real time, as a excuse me, as an ECM manipulates the bus voltage, right? It changes across the entire bus at once. Everywhere on the bus sees the new voltage instantly. So on real time, right? As the ECM manipulates the bus voltage, it changes, right? It changes across the entire bus at once. So you're going to see these changes instantly taking place. All right. And if you're next to a data link that is working properly, you can see that system. So let us go down. So we mentioned that can signal, there's the can signal, right? Let us look at the vocabulary, right? Can follows a convention, right, in electronic signaling called non-zero um to non-return to zero inverted, right? And that may seem a little unusual if this is the first time you're seeing this sort of system, right? Let's take a closer look. The signal is mirrored between the can high and the can low lines, right? It is the difference between the voltages on these two lines that provides the signal, right? So the signal, which is just pulses of the differential voltage on the bus, represent a binary digits, right? Or ones and zeros. Binary represents a binary digit, a binary system, a binary system. So this here represents a binary system, ones and zeros. Okay? And so when we talk in differential, the differential is a recessive voltage, right? The differential is you're gonna have the recessive voltage, right? Which is 2.5 volts. That is the differential between the two, right? Between these two here, between the two, that is a differential. There's no differential in the recessive bit because this is, they don't have an inverted or an upper grass. So this is one line. Okay, so there's no in the recessive, in the recessive bits. You have recessive bits at the top here, recessive bit at the bottom. There's no differential. There would be zero differential there. Okay, so remember, dominant bits, this is dominant 0, right? This is dominant 0, this is dominant 1. Okay, and so this here at the bottom will be dominant bit as well. Dominant bit, dominant bit. And your dominant bit is what we call 0 bits. And your recessive bits is what we call 1 bits. Okay? Let us do it. So 1 bits are also known as recessive bits. 1 bits are represented by the lack of differential voltages. All right? 1 bit is represented by the lack of differential voltages. 1 bit. 1 bit. Right? It's a recessive, right? The recessive voltage, there's no differential there. All right? There's 0 differential. Okay? So now, so this is the end of the topic that we were talking, you're in the comfort zone, and we're talking about introduction to CAN bus. So we're gonna go through some simple things now, practically. Now we're taking our multi-tester, right? And we want to test, right? And now the next 4 minutes, we're gonna go through this. We want to test our CAN data link because we acknowledge or we observe that on the monitor or on your HMI, it's you're not reading oil pressure, you're not reading coolant temperature, right? There's information that you understand supposed to be coming from your ECM that you're not seeing on your HMI or on your monitor, in your excavator operating station. You're not seeing, right, oil pressure. You're not seeing temperature, right? And then on the monitor saying you have data link error, right? You have a data link error. You have a code up there. Whatever code it is that is being assigned to that sort of fault, you will see there. All right, and it will say data link error, or you might just see the code and you want to know what is it, but you're not seeing oil pressure, you're not seeing coolant temperature, and this is something is happening, right? So I want to test. You get your schematic, and you look at your CAN data link, because your CAN data link is the one responsible to sending information from your ECM to your monitor. And remember that if you're doing welding on a machine or excavator, you want to put on something, buckets or whatever, you understand, you need to disconnect, right? Lock out the system, disconnect the battery, take off the wiring, the harness connectors from your ECM, remove it for safety reason. You don't want to be welding and sending voltage in through your CAN data bus, because if you send voltage through your CAN data bus, then you can damage your transceiver in your ECM. The other thing that can damage the ECM data, the CAN data link or the CAN data bus or the transceiver in your ECM is lightning. So if the lightning, wherever your machine is, you had a severe lightning strike, right? It can shut your CAN data link down. right? So you can test with that. And remember, if you have your machine off, right, and you testing resistance on your CAN data link, the CAN high and the CAN low, the two wires, right? Remember, it's between your meter have to go to the chassis of the vehicle or or the machine, right? You must go to the chassis of with your multimeter negative, right? The negative lead to the chassis, and you use your positive lead on either CAN high and CAN low. There's only two wires in the data link or the CAN bus, right? You have high and low. And when if you testing resistance, right, in this data link, right, when you testing resistance, your 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 resistance reading must not your resistance reading must not be low. It must, the values must not be lower in the mega lower than mega ohms. It must be up in the mega ohms values, right? So whatever you read, it must not be kilo ohms, must not be ohms. If you're reading 50 ohms on your high, then therefore it is grounded. You have to change that. Or you also have to remember that you have to remove your your resistors, because remember your resistors is across this thing, right? And you can remove your resistors and also check, right? Remember when you're doing that, your machine is powered down, the system is powered down, right? Battery is removed, right? And you just checking the data link resistance. Now if you go across your data link, right, if you have the two resistors end to end, right, it's 120 ohms resistor. But when if they're end-to-end, that means that they were in parallel with each other. So it would be half of 120, and half of 120 would be 60 ohms. So when you testing with your meter, you're testing and you're looking for 60 ohms. All right. So if you're getting 120 ohms when you're testing across your CAN high and CAN low, and you're getting 120 ohms, then therefore one of the resistor is open, and that can interfere with your data going back and forth on the system. So you need to rectify and see which one of the resistors are open, okay, on your CAN data link. And so you remember, before before I leave you, CAN low, it's non-return to zero. Remember this. This non-return to zero system here with the CAN data link, right? In electronic, it's non-return to zero. It's not going to go to zero. You see, it's riding over above the zero line. So this is the zero line. This 0 volts line here, and your pulse is riding above that. Okay, so it's not zero. It would never be zero, but your differential is gonna be half of it if it's 2.5. Most system is 2.5, and so you were in the comfort zone, and I was bringing this topic introduction to CAN bus, and I do hope you enjoy this moment. I do hope you enjoy the lessons and you can take all these information. Remember, when you measuring, remember if you're measuring your data link, remember if you're measuring your data link, if you're measuring resistance, please remove power from the ECM, right? You just want to measure your resistance on the bus, right? Remove power from the ECM, and remember that your resistance value on a CAN bus always have to be up in the mega ohms value. right? You must, for a good data for a good CAN data link, right? The resistance will be up in the mega ohms values, right? It must be in mega ohms, 20 mega ohms, 10 mega ohms, 15 mega ohms, but it must not be below the mega ohms value. Kilo ohms, then there's something wrong with your system. Remember that you can remove your resistors, the two 120 resistors in the circuit, just to ensure that that you when you read in the pure system. Remember also too that if you have more than one ECM in the system, you can remove the data link from, if it's two ECM, if it's one ECM, then therefore you all right. You just check in this one ECM, that from ECM to monitor. But if you have several ECMs in the system, then you have to check this. You got to check and see which one of the ECM transceiver is defective. You could have a lightning strike, right? That can damage your transceiver circuit. All right, so I do hope you enjoy this topic of the introduction to CAN bus. And the next topic, I want to start with you. Let me go back here. I want to start. I want to start with you. It's gonna be same can I'm gonna be talking about CAN data link, but I'm gonna talk about CAN data transfer process and message in structure. So the next topic would be CAN data transfer process and message structure. We're gonna go through that, and so you could able to understand the messages structures in the CAN data link if you're getting into electronics. All right, and so I do hope you enjoy the topic, and God bless you. You have a pleasant day, rest of the day.